So guys, today we will cover a very special topic, and let me open the editor to explain the stuff. So what we will do now is implement a custom solver, because as you might have noticed, we cannot constrain bones or IK bones, or the current retargeting stuff does not take care about them. And yeah, I was trying to find a solution there, and yeah, I struggled kind of a lot to find a good one so that we don't have to constrain them all the time. And also, what is really annoying, you can configure those IK chains or bone chains for the IK bones, but it will not take care about them. So we cannot use this tool for our use case for ALS currently. But what you can do is the following. So if you go to the solver documentation, there is described which solvers are present and so on. And in my view, the easiest one to understand is the set transform solver. And what I will do is also, this link will be down in the description below, so that you can read about those solvers and so on, how they work. But what it does not describe is how they are implemented. That's more like a user documentation here. I don't know yet if there's an API documentation yet, but so far seems not to be the case. Yeah, I did not found them. So if you know where this is described, what we will cover today, please put it down in the comments below so that I can update the links of the video. But anyway, so if you know that this might be the easiest one, the other takes care about bone chains and inverse kinematics and a lot of stuff and so on. So yeah, you can cover a lot of stuff. How the set transform solver works is basically you introduce this solver here with add new solver, and then you have a new IK goal which you can connect to this solver, and then you can use limp IK solvers. And look at this, then you can move this transform, and it does take care about the knees and the legs and so on. And I thought, that sounds very interesting. Can we use this for constraining our IK bones? I tried it, but it never worked, and I said, strange, why does it not work? And how I work most of the time Unreal Engine is, but that's only the case if you are very familiar with C++. I read the engine code, and there I found out, oh yeah, it would only work if this IK goal would be driven by the bone which is connected to it. But sadly, this setting is not yet exposed for us users. So then I was stuck, and I said, how could I implement such solvers? And what I did is go to GitHub. I will also put these links down in the description below so that you can read this code as well on GitHub. I will also show it later in a few minutes how we can see this code in Visual Studio. So if you go to Unreal Engine, the repository from Epic Games, we go to Engine, Plugins, Animation, IKRig, Source, IKRig, and then we found same structure, our public folder. And the public folder contains the header files. And there we can see, oh yeah, there's IK solver. That sounds very interesting for us. So we open it. So I'm using the middle mouse button here. So in case you don't know that, we can open new tabs with it. So and here is it's a lot to read, really a lot. It's quite a complex interface, or abstract base class, which you could say. And we have also some methods which are only available in the editor world and so on. It's way too complex to get started with it in my view. And you can read ages ages on it, and you might not understand. I said, that's too complex. Let's see what is else there. So I go back to the folders and said, oh, there are solvers. Interesting. And then there's the transform solver. So here's the transform solver. And how it basically works is, implements the or overrides the initialize function or method and the solve method. And those are the most important ones. The other stuff is just for configuring the system, like update solver settings, get a nice name, display a warning, which you might have seen already if you have not connected the IK goal. You can add you can implement the function or method to get notified when IK goals are introduced, if the user removes one, if one is renamed, if one is set, the bone, for example, for this IK goal, and if the IK goal is connected to this stuff, and so on. So yeah, that's basically how you can get it working. And for the settings, it's very interesting. For the seconds you can introduce a custom struct, which is for each instance of an IK goal, and then you have custom settings in the UI basically. So maybe let me show this to you as well. So if we click here, we get special settings, and these are the structs which you can implement. It's a custom one, and yeah, that's something you can do. And then I still wanted to know, how does this work, and how we can find out is the following. We go a little bit up in the structure and go to the private folder, and there we have the same folder name. Here's the solvers. So here's also IK-rig solver CPP. So it's quite only a few methods: post load, post transacted. I don't know what is this for. We don't need it, but that's how you can read the code if you want. But we are currently interested in set transform solver. And here's the stuff. So basically, in the solve, we can work with the pose or with the bones. For example, here we have the effector settings, and if the position and rotation is enabled, it will try to lerp between them. So here's the current pose, and then we use the location for the IK goal. That's why I said, yeah, it would be nice if you can use it, but it doesn't work. And here you also have an alpha value, and yeah, that looks quite nicely for us, because then we can implement a custom solver, which we will do in a few seconds. So yeah, and initialize, you will get called when the solver is instantiated, and you will get access to this IK-rig skeleton, where you can ask for bones or indices and so on. And yeah, that's how you can basically get it working. And here are the settings if you want to use them and so on, but we will not use this. So that's how you could read the code on GitHub. What is also quite interesting is the following here, this one. So if we, for example, did not know that where is this class also, we could paste this to the clipboard and maybe search for set transform. I'm pretty sure we will find a lot. So here we have a lot of lines, but what you could do is, let me check. So maybe you are smart and know that we are searching for IK-rig solver. Then we could try to find them here, and hopefully, yeah, get less results. So here you would see where this file is. It's a very good search. I can really recommend using it if you don't have access to Visual Studio or want to search quickly in the code base and see what is going on there. But yeah, now the main question is how we can get it working. In the following, we can do the following. We go back to the editor, and we will let's say let it open, and we will go to our plugins folder, TT Toolbox C++ classes, then TT Toolbox again, sorry guys, and public. And there we can do a right click, new class. And here we can click on all classes and search for our IK-rig solver. That's exactly what we want to implement. And then we need to come up with a proper name. So maybe this is not the best name. So if you find a better one, please let me know, then we will change it. But to get stuff basically working, I use the following: IK-rig underscore bone constraint. I'm not sure if this is correct. So IK-bone constraint is already used by another class. Right, let me check what's going on here. Maybe I did something wrong. Toolbox public. Now it should work. Why does it not work? Wait, let me quickly recompile the plugin. Maybe that's the issue. Because I was already working on it and tried to get it working in my way. And now I want to share the process, how you can implement it. It's an alternative method to ConstraintBone directly doing retargeting, which is super helpful. So, come on. Seems to be my computer is lazy already. So, let me check if it works now or not. Hopefully it works now. Next. IK_rig_bone constrainer. No. Bone constraint. ConstraintBone. Let us call it ConstraintBone. Sorry. I don't know why it doesn't work yet. ConstraintBone. So we create the class and we select here editor and so on. So it quickly recompiles stuff for us. And then we should be able to start implementing our constraining algorithm. So here, if I move Visual Studio to this, to this window here, or the screen, then we see that we have this minimal stuff here, and we just remove this one. So remove this one. So, and what you can do is, if you want to know how the interface looks like. Why does it not? Oh, that's strange. IK_rig ConstraintBone. It does not derive from the right one. Interesting. Wait. Wait. That's strange. I selected this one next. Seems not to work. Strange. That's very strange. I don't know why. Maybe you are more lucky and get it working, but it seems to be that I'm not able to get it working. So, but we are smart. We know what we are doing. So here I do the following. I say Unreal Engine includes, and we introduce this file here. I say include quote solver, and we need to derive from this one. So what you can do now is select everything, right click, and go to show code. No, I want to go to definition, but it seems not to work. F12, no. Oh, today's everything is really messed up, because I wanted to know the base class, basically this one here, and we say public derive from this class. And let me also quickly check something. So we need to say, I don't know why this is used, but this was used in the set transform solver. So what you can do is, let me see. So if you know the name, chicken egg problem. If you know the name, you can press Control and comma and then paste this name in, and you will find the implementation here. And as you see, it's called uClass edit inline new. So if somebody knows what this is doing, please let me know. But we will move on and try to implement the solver as fast as we can. So we also need this generated body here, and we have the constructor and destructor here, which is fine. And let me check what is else needed. So we need to introduce a new structure, and that's this one here. So we need to introduce a new structure, and I call it F ConstraintBone, and it's, wait, let me move this here around. It's always crazy. So this really correct? IKRix, so yes. So this struct contains the constraint bone, basically the bone which we want to constrain our modified bone to, our IK bone or virtual bone. And as we are using the same names here, we will be able to reuse our data from the data table. And then we can say, yeah, edit anywhere. We can say blueprint read and write, which basically makes this structure usable in blueprints as well. So if you want to use it later, we can do if you want. And then a custom category, we call it constraint. So if you come up with better names, please let me know, comments below. But yeah, let's move on. So, and what we can do then is the following. We can also introduce a next structure. So this one basically, which is basically the structure which we want to use for using as settings. And here we just use the following approach. We also say it's a U object. That's what you need to use or can use basically. No, no. Sadly, the code I wrote is very garbage. So what we do is the following. We use this approach here, and we put this variable into the protected section and this one, and we expose this. So we say it's a U property, edit anywhere, give it a proper category, set transform category. So settings, call it settings. Let's call it settings. And there we have the ConstraintBone array, which is T array, and it consists with the data type we introduced above here. And then we move on. And we will need some private variables. This one here. So let's open a private section. So this is an internal structure which just stores later our indices for the bones in Unreal Engine. They are stored internally as integers, and the names are basically is for us, for the users or for the developers, because we cannot remember all the time. Is it 5 the bone on the right hand, or is it 6? So you just say hand underscore r, and internally it's mapped to this integer for performance reason, I guess, performance reasons. And there we also introduce an T array and use the internal structure we have here and say m underscore constraint bones, and then we can use this later if we have it initialized. So let's introduce the initialize method. And what I do as well is open here a protected section as well. Here we can say protected exposed members, and here we say protected IKRix solver interface. And there I always remove this virtual from the method because it's not needed, and I say void initialize const FIKRix skeleton and IKRix skeleton, and we say override because that's a abstract base class method which we want to use for implementing our initialization stuff. And we will do this here, and yeah, just write the code here. So in case I was too fast, what you can do is the following: do a right click, and there is something like switch between source code and header. So it's still in German here, but it's the shortcut Control key O, and then you can switch between them if you click here. Or you can press Control K and O, then you can switch between those files, but not most of the time it will not work in Unreal Engine. So press Control and Tab. So that's fine. We remove the override here, of course, because in C++ files we don't need this one. And we implement the following. So here we have our private variable, which we just reserve and say how many bones we have with this num. So this constraint bones basically is is this one here, this T array, or this one here. And yeah, so it's also for performance reason, then we already reserve the size of the array. That's why I do this all the time. And then we just iterate over all bones we have and try to add them. And here we can use a C++11 feature, which we use this brackets here and say, yeah, the first value is this ConstraintBone from our structure, and we want to have the indice or the index basically of this, and there we can ask the ikrig skeleton, say get bone index from name. So basically we convert a name to an integer and then store this in this array, and then this part is already done. So, and what I do as well sometimes is, if you look into my code, is this. So I use this docgen notation where we say // this sign, I don't remember the English name for it, sorry, add to do add FFS, and FFS is for further study, so I can do it later. It's not needed to get the system basically working. So I will also cover this in a new video, not in this one here. We just try to get stuff working as fast as we can, and then see if our approach works with the solver already. And here I format the code a little bit more, because we will not work with this ctors and detour stuff, so constructor and destructor, but we will work with the solve method. So we need to introduce the solve method, and that's this one here. This has this signature, this one. So we remove the virtual as well, don't need it. So we say void solve fikrig skeleton ampersand ikrig skeleton. So basically it's a reference, and then we have a const reference as well, where we get the ik goals, which were selected by the user. And we copy this one into the clipboard as well. So here you can press the pos1 button or the end button to get at the end of the line or at the beginning, and press shift to select everything, and then control KO as well to go back to the C++ world. So you can use shortcuts, you can also use the mouse if you want, but I prefer to use shortcuts all the time. And we introduce the class name here, of course, and then we say, yeah, this method belongs to this class. And what we do is the following. It's very easy to implement. You cannot imagine how much time this will save us, and how much headaches it will avoid for us. So we use this code here basically, and when we have no setup bones or indices in this array, we will just return and say nothing to do here, as no constraint bones are configured. So we will also not raise an error message, because this message is called a lot, many times, when Unreal Engine or IK retargeting tries to update the pose. And then we iterate over all bones, get the ikrig skeleton, and say current pose global. That's an array where we use the index basically from our ModifiedBone. Then we call the ikrig skeleton again, say global current pose global, and use the bone we want to constrain our ik bone to. And then we notify the ikrig skeleton that this bone has changed. So propagate global pose below bone. That's the method we want to use. That's what I learned from this set transform solver. And if you want to dive more deep into it, I would recommend reading the code. But it's basically is it already, and it should work now. But we want to introduce some more stuff for our users. But let's at first check if it already works. We try to compile the stuff. So here we use hot reload and see if it works or not. The build failed. Missing public inheritance in line 21. So let me close the editor. We will open it again and do the build here as well, so that we see what is going on. So in my case, it's the F7 button, but sometimes if you go to build here, that's the first one, there's Control Shift B or something like that. It depends which language you use during installation. But anyways, so here it says line 21, and yeah, it cannot work with this one. So, and what we missed is the following: this include, because this is the very most important include you cannot imagine for Unreal Engine, this one here. So we cycle rig, let me check how it's called. So yeah, dot generated, that's the generated code for the reflection system. So let me check if this works. Missing public include, still the same issue, missing public inheritance. Oh yeah, a typo from my side. So here you say public, now it should work hopefully. So class name is invalid, should be identified as U. That's strange. Abstract. Okay, that's interesting. I did not know, but let's use this name if the tooling is telling us that we are doing something wrong. I did not know, sorry. But now it should compile successfully. So a class cannot inherit itself or a type the same prefix. Why does it not work? UIK Rix, it was correct. Oh, Unreal Engine is doing something really weird to us. We need to use a U here. That's basically the naming convention of the classes in Unreal Engine. That's strange. So, what does not work? What did it not like? So here it says some types cannot be. Yes, of course. If we rename the class type, we need to rename this all as well and go into Control O into the CPP file as well. So as you see here, I don't know why IntelliSense is messed up on my setup, but somehow it is. So hopefully it's now better. So yeah, I hope you learned something. I did learn a lot. that's the important one. So we do the following: right click, go to folder, and use the file. We want to start the editor again, and we want to use or want to know if the solver is already present for us in the window. Hopefully it is. So let me open the IK rig again, and here we should be able to click on solver. No, it crashed. Assertion. So what it did to us: enclosed block should never be called. IK rig solver line 58. So yeah, it's not the minimum which we can implement. Line 58. Ah yeah. So what I did is Control G, and then you can type in a line here, and you get directly to the line where we have the issue. And this is the virtual method which says get nice name, check no entry. But yeah, we did not implement this one, so let's copy this one and yeah, work on this one here. So we will just continue here, and of course say here override, and then we have this nice name here, and we need to introduce something as well. So because this is only an editor call, so it will not get called when you package a full game or so. And you can see this if we go back to this file here with editor only data, and that's that's something you need to take care of, otherwise the build will fail. So ikreg constraint. So let's see if this is already enough to implement this feature. Basically, we will need more, but we try to always get stuff working as fast as we can to have the possibility to iterate on it, or have something to play with. So in here we can say local f text, local text, and we need also to use the name here of course as well, and solver name, comma, quote, and then we say constraint bones. We just rename the stuff here, constraint bones. That's what I was using for my prototype. So let's see if we can build again. So here you go to build and then click on build solution, or you can press the button F7 or shift control shift B. So, and sure, there's something missing as well. We need to introduce this define here, and I think on the end you need to undef the define. Don't ask why, that's how Unreal Engine works. You basically need these ones, otherwise you cannot use this local text macro stuff. But now it should work. So we have a successful build, and we go back to our editor and start it again. So it's very sad that it closes the editor and says assertion and we need to restart it. But yeah, that's how the interface was designed by the developers. We are just using it for our use case. Let's see, where's the editor? So open this one again and let's add the solver. Now it works. As you see here, we have constraint bones, and what you can do is the following. You can set the order basically of those solvers, but what we want to do for our use case is use the full body IK solver and then use the ConstraintBone solver afterwards. So it basically sees, oh yeah, this hand, for example, you can move this one here. This hand moves to here, and this bone then should be constrained here to this hand bone. That's what we will implement, or what it should do already. And what you see as well, if we go to this constraint bone, here we have this constraint bones array, and what we can do is the following. We can go into the scene view, go to plugins, content, data tables, and we open the constraint bones here. Do a right click, copy everything, and we open a new text editor like Notepad++, and you can double click here, press Ctrl H, and replace this name here with ModifiedBone, and click on replace all. Same we will do for this one. Double click again, Ctrl H, and then I already was working on this one. ConstraintBone, replace all, and copy this again to the clipboard. And magically do a right click here, paste, and bam, you have all the constraint bones as well, like we have in the data table. So we can use this now here as well for our UE5 Manny. So that's how we can reuse the data and don't have to tackle them again, and that's the correct order. So you need to constrain the bones in the correct order. So this one should be already properly set up for you. I will also add this in the link in the video down below, so that you can just select it and copy paste it. But that's the process how you can convert this from a data table to a string, which we can use for the clipboard, and then paste the stuff here as well. So it should work already, but what is missing, basically, we do not see which bones are affected by the solver. So what we can do is the following. We just go back to Visual Studio and we implement a new stuff. So let me move this to the other screen so that I can explain the code better. So here we have the following, this method here. So let me go Control O and go down below. So we move this like, oh no, that's that's not our code. close this one. We will not need it anymore. Use this code here, remove the virtual. And we say bool is bone affected by solver. It has this signature here. It's const fname reference bone name, const ik skeleton reference ik skeleton. It's a const method, and we want to override it. And then we copy the signature to the clipboard as well. Control O to the CPP file, and we will work on this one here. Again, we need to use class name. We remove the override, new line, and introduce those brackets here. And what we will implement is the following. So magically you will see immediately what we're doing here. We have this constraint bones. That's our structure we define in our array. And if we iterate over all of them, we use a reference here to save the work that needs to be done. If you want to copy the f name basically, and then we check this bone name matches a modified bone name from us, and then we just return true. Otherwise, if it will not fit, we will return false. And if we save everything again, where is it? Save everything, Control Shift S, like an Unreal Engine, and then we go back to the editor as well. Somehow it closes. Oh no, that was the old window. We can go back to the scene view and click on the small button here and trigger our live coding. Let's see if this works. That would be very interesting. This works. So it was modified, and then I think we might have, no, it works. So if we select them again, you will see those bones now get white, so that we know if we have these bones here. Let me copy this to the clipboard again and remove them. Then you should see no bones are affected anymore. If you do a right click again, copy paste stuff, click here again, you will see it's affected now. So we know those bones are affected. And what is also interesting is, as you might see here, we can also modify virtual bones as well. So they will also get constrained doing retargeting. So, and what we can do now is the following: remove those unnecessary bone chains. So left foot IK, right foot IK as well, handgun as well, foot IK as well, hand root IK as well, left hand IK also, right foot IK. So as you see, it will remove a lot of boilerplate stuff on our IK rig because we can now use the solver here. And let me see if it still works already. So this is the solver we want to use, but where's the retargeter stuff? So where is our retargeter? So we go to content, characters, mannequin UE4, rigs, and here we have the conversion from UE4 Manny to UE5 Manny. And here you see we still have those IK chains, maybe, probably. Not sure, maybe I removed them already. Let me check. So where is this one here? So it's this IK rig. Oh no, I did not, but we can remove them now and save some work for the tooling, because this one is not affected anyways now from the solvers. So remove all of them and save the stuff. Save it. So let me see if we can retarget stuff already. So we go to the solver here, and what you can do also, as I said, the order matters a lot, and you can also disable the solver. So it should now not be called anymore. We also save everything, because maybe I did something wrong and the editor will crash when we try to solve it, but I think it's not the case. So let us use a sprint animation also from ALS, sprint, so sprint forward. So as you see on the UE4 Manny, the bones are constrained, but let's retarget this animation to the content folder and then open this folder and open this animation. And you see the bones are not constrained. Even the virtual bones, they are messed up, and it will create a lot of trouble for us for ALS. But let's make it a bit more interesting. So save this and close it again, not save it, close it, and we will redo it again. So go to the IK mannequin solver from the UE5 Manny, save everything, and enable the ConstraintBone solver, and go back to retargeting and say export select animations again to the content folder. And here you will see magically amazing, right? Insane. Now we have ConstraintBone and it works perfectly fine for every animation. So also if we stop the animation here, you will see that those bones VB, foot, target are constrained. The knees, virtual bones are constrained. So it just works and it saves us a lot of time and a lot of headaches, because now we can just use those solvers. That's how you can implement this solver. But let's make it a little bit more polished. We can still improve it, like all the time. You can always improve. So what you can do is the following, which I don't like, to be honest. You can here say new IK goal and nothing will happen. Maybe it closes also the editor. Yes. So yeah, it crashed the editor for us. And the reason is that we did not say this interface. We don't want to use IK goals. So what we can do if you go to the header file again is the following. Can overwrite this method here. So its bool is goal connected, and then we have the signature const fname reference goal name const overwrite. And what we do is go back to the CPP file. Let me check. Yep, CPP file, and use the class name, of course, again. Remove the override. I think we get already bored. And just return true all the time. Because the following, which I documented, is the following comment here. So always return true, as we don't want to connect IK goals for this solver, and then a smiley. So hopefully someone who will read this comment will know what we are doing. And let me check if there's something else missing. Yes, we need to introduce this one as well, this if with editor definition, and also close the section here in the end. And we want also to give some feedback to our users, so we override this method here. So override this method, remove the virtual, and go back to here. So implement the signature, the frame to implement stuff, and go back to example code here, and we will introduce this code. So with a few lines you will get a very good solver. So what it does is it gives us an f text reference, an out warning message basically, and there we can check if we have constraint bones less than 0 bones, and then we can just use this log text and say no constraint bones, missing constraint bones, and we save everything, build everything, and then hopefully the build will be successful, even if IntelliSense is messed up. So yeah, that's fine. And we open the editor again, so hopefully we did not lose our settings and I was able to save the stuff. But yeah, let's see. So yeah, it did something really weird to us. That it crashed the editor because we did not implement the interface properly. But yeah, let's open the IK rig again. We can also click on open and check. So IK bones are removed here as well. And what we can do now is the following: go here to the solver, say new IK goal. Does it still crash the editor? Why? Wait, let me check. pure virtual not implemented add goal. So did I implement this one as well? Maybe I did not test it. Oh, it's not implemented. So IK solver, and let's search for add goal. Oh, that's a pure virtual method. Oh, we need to implement all of them, otherwise we will still see those assertions. Is there more of this stuff? Hopefully not in this interface. So initialize we implemented, solve we implemented as well, so that's fine. Then I would say, yeah, it forces us to implement this stuff, and we will do it if this is needed. So I implement this stuff, but we will not do anything here, just empty methods. So we can still write them down in the header files, and we also need to say override, of course. Override, so pure virtual override. Good that we test stuff. Override, and you also know what could go wrong. So we recompile again, and hopefully we have a successful build. Let's see. It's a longer session. Sorry guys, I did not prepare it very well, but I think it's very valuable for you that you know how to solve those issues if you step into them, like I do currently. I did not know that we have to implement them. But yeah, you can just implement them as empty methods, because we will not use those methods in our solver to constrain our bones. It's not needed. So we click here, and we should be able, yeah, it will add the IK goals, but we cannot. So it says disconnect goal from solver, but it will not do anything. That's why, the reason is that we just return always true. So because this basically just hides this connect goal to selected solver, and we cannot do anything here. I know it's a bit weird, but it's a lot better to use, and it's not so confusing for the users that you try to add goals and it does not do anything, because we did not implement the settings here, the setting stuff, and we just want to ConstraintBone. So that's perfectly fine if we click here and then use this stuff here. And that's basically, is it? Or did I forget something? Let me check quickly. No, that's basically how you can constrain bones with this IK retargeting tooling with a custom solver. So yeah, I really hope that you like the session, and see you in the next one, where we will work with Git, and maybe yeah, in another series where we use this ConstraintBone solver to get Twin Plus working. So yeah, stay tuned for updates, and if you did not do it, subscribe to the channel or to my Instagram account to get updates when new videos come out. So yeah, happy coding to you, and now happy constraining to you as well. See you.